Welcome back. Section 1.2. We call this congruent segments. A couple things before we get started. One, again, I would encourage you to have the notes out so you can pause the video when I tell you to, and you can try a couple problems here and there. And two, I would also encourage you to subscribe to my channel. This way, if you are trying to go back and forth between videos, you don't have to go back to Schoology every time to look for them. Just right there, you are a subscriber. You can look at all my videos when you want. Don't worry, all my videos are math related. So you can learn lots of good, interesting mathematical material on my channel. So let's get started with section 1.2, again called congruent segments. You see your goals listed at the top there. A lot more vocab again today, and a couple new types of problems that we'll take a look at later on. So first, this new word called congruent. So we're talking about congruent segments here. Those are simply two segments that have the same length. If you were to measure them with a ruler or a tape measure, they would be exactly the same. How do we show that on a picture? We use what's called tick marks. A tick mark could be pretty much anything. The most basic tick mark is just a simple dash. So as I zoom in here, I put a dash here and a dash here, and since those have the same tick marks, that means they're congruent. Okay? Now if I was to do this, that means they're not congruent because they have different tick marks. But I'm not going to do that because they are congruent, so those two are congruent. That's why they have the same tick mark. Can you use more than just one dash here? You can use two dashes, three dashes, a triangle, a circle, whatever you want, as long as it's the same shape on both figures. These segments are not congruent, so you don't have to put different tick marks on them. You just leave them blank. If they're blank, that means they're not congruent to each other. So we say FG and HJ are not congruent to each other, okay? So writing this, let's go back to this one here. The new symbol here. So these are segments, remember from 1.1, to write the segments, we put a little segment hat on top of it. So segment AB and segment CD, and we want to say they're congruent, we put a new symbol in the middle. It looks like an equal sign with a little tilde on top of it, and that symbol means congruent. That means those two are congruent. If I go over here, segment FG, segment HJ are not congruent. So it's a little congruent symbol with a line through it. That means not congruent. Okay? Next word is between. Between is exactly what you would think it would mean. It's between 2 points. Okay? So point A is on the same line as points B and T, and BA and AT add up to BT. So if we're to draw that, let's draw a little segment out here. And we have B and T are the endpoints. And anywhere on that, we're going to put point A. So let's take a look at this here. BA plus AT equals BT. Well, that makes sense. If you add BA and AT together, you're going to get the big segment BT. And that's what betweenness means. It means that the two little segments will add up to the big segment. Okay, the next word is midpoint. So if you look at this picture, would you say A is the midpoint of BT? I hope not, because A is not in the middle. Okay, if we moved it a little bit over to the right, it looks like it would be in the middle. Because what is a midpoint? It's a point at the exact center of a segment. So in this picture here, this point is the midpoint. It's exactly in the middle of those two. How do we know it's exactly in the middle? Well, we're going to put tick marks on both sides. I'm going to use 2 tick marks here just because I want to change it up a little bit. That shows me that those two segments are congruent, and that point is exactly in the middle of the two endpoints. Therefore, that point is called a midpoint. Last vocab word here is a segment bisector. A segment bisector is just a line or a ray or a segment that goes through a midpoint. So it's also going to cut a segment in half. So in this picture, this ray is a segment bisector. So it makes these two segments equal. This segment is a segment bisector. So it makes these two segments equal. I'm just going to change up my tick marks here so you can see I'm making different tick marks. In this picture, this line is a segment bisector. So again, changing up my tick marks here, I'm going to put circles this time. But again, it shows that those two segments are equal because the pink line segment or ray is bisecting. The word bisect, really simple. Sect means to cut, and I think you all know what the prefix bi means. It means two. So a bisector cuts something into two equal parts. All right, so we'll do a couple of problems here together. Number 1 says, name the congruent segments in the figure. Well, you see 4 different tick marks here. 1, 2, 3, 4. But they're the same tick mark, which means all 4 of those segments are equal. So let's write them down. AE is congruent to BE, which is congruent to DE, which is congruent to CE. How do I know that? Again, it's just because they have the same tick mark on all 4 of those. So they must be congruent. Name the midpoint of BC. Now here's BC. What point is in the middle of that cuts it into 2 equal segments? Well, that's just point E. And number 3, name the segment bisector of AD. Well, here's AD. What is the name of the segment that cuts that segment in half? Well, that would be this segment. So segment BC. So in that problem there, we call BC the bisector, and we call AD the segment being bisected. That's a big difference in vocabulary there. Okay. Stop the picture here, and go ahead and try 4, 5, and 6 on your own. And when you have at least attempted all 3 of those, go ahead and come back. Okay, number 4, we have 2 different answers here. You can see ZX, this is how I make my Z's, by the way, I put a little line through it, is congruent to YX. And you also have the double tick mark, so ZP is congruent to YP. And some of you out there might be thinking, well, I wrote PY. Yeah, that's fine, okay? If you wrote ZP and PY are congruent, that's fine. Remember, for segments, you can mix up the letters. The only thing you cannot mix up the letters on is rays. Number 5, name the midpoint of ZY. That would be point P. And number 6, name the segment bisector of ZY. So the question is asking, here's ZY. What is the name of the segment that's cutting that segment in half? It would be XP. And again, make sure you're putting segment hats on top of all these segments. All right, next slide. The distance between any 2 points is the length of the segment that connects them. So here, we already know this one. That's called segment AB. That's the actual physical segment. Okay, that's something like you could pick up. It's a pencil. It has an endpoint and an endpoint, and it's something you can actually physically pick up. Okay, if you take that segment hat off, it no longer is that segment. Now this is called the measure of the segment. This is a number. Okay, it's like 7 or 46 or any other number you can think of. Okay, so the big difference is the segment hat. If you see a segment hat, it's a physical segment. If you don't see a segment hat, that represents an actual number. Okay? So if I'm finding distance, basically on a ruler, it's pretty easy. You can just subtract the numbers, biggest minus smallest. Okay, but something you should think of here is that distance is always positive. Okay, when you drive from your house to the store, you drive 3 miles. Okay, but when you drive home from the store to your house, you don't drive negative 3 miles. You still drive 3 miles because the distance is always positive. So if I'm looking at the example here, EJ, and I see E is at 1 and J is at 7, and I make the mistake of doing 1 minus 7, and I get negative 6, that's okay. Just remember to make your answer positive, and the answer is 6. Okay, but really, if you can just remember to always do biggest minus smallest, you'll get that positive number. Okay, please pause the video here and go ahead and try 7, 8, and 9. For number 7, EG, you should be doing 5 minus 1, which is 4. For number 8, you should be doing 2.5 minus 1, which is 1.5. And for number 9, you should be doing 5.5 minus 2.5, which is 3. And notice on all those, we don't have segment hats on them because they're representing numbers. All right, very important part here coming up, something we'll use probably for the rest of the year in geometry. 2 small segments adding to a bigger one. So look at the picture here. On segment PR, Q is between P and R. Is that word again, between? Q is between it. It's not the midpoint. So don't think that those 2 segments are equal. It does not say midpoint or bisect. Okay? Between just means that the 2 small segments add together to give us a big segment. Okay? We know PR is 16. We could find QR. So using letters, I know that the small segment PQ plus the small segment QR equals the big segment PR. I know PQ is 9. I know QR is X. I know PR is 16. Subtracting 9 from both sides, we get X equals 7, which means QR equals 7. I'm supposed to put that over here. You're probably thinking, oh, that's really easy. And you're right, it is really easy. It can get a little more complicated, and we'll take a look at these problems here. I'm going to do 10A with you, and then I'm going to ask you to do 10B. So 10A, it says right here, important information. N is between M and P. I'm not even going to look at the rest of the problem. I'm going to stop there, and I'm going to draw that picture. So draw a segment where M and P are my endpoints. And then anywhere on that line, put N. And now I'll fill in what we know. I know MN is 3x plus 2. I know NP is 18. And I know MP is 5x. Okay? So now looking at the picture, I know that small segment MN plus small segment NP must add up to big segment MP. I also know that MN is 3x plus 2. And NP is 18, and MP is 5x. Now this becomes a very simple algebra problem that you solved probably 100 times last year in Algebra 2. Combine like terms. Subtract 3x to the other side. Divide by 2, and we get x equals 10. Now, very important in geometry class, x is usually not the final answer. Look at the question. What is it asking us to find? Find Mn. This is Mn. So Mn is 3 times x plus 2, which is 3 times 10 plus 2, which is 32. So our actual answer here is Mn equals 32. Pause the video, and please try 10B. Okay, hopefully you started by doing this and labeling that GH is 6x minus 5, HD is 2x plus 3, and GD is 30. And then we know GH plus HD equals GD. Substituting, we get 6x minus 5 plus 2x plus 3 equals 30. Combine like terms, we get 8x minus 2 equals 30. Add 2 over, we get 8x equals 32. And divide by 8, we get x equals 4. But again, that's not what the question's asking. It's asking for GH. So GH is 6 times 4 minus 5, which is 19. You are free to use a calculator on anything in this class. There is only one chapter in the second semester that we don't use a calculator on, but everything else you are free to use a calculator all year. Okay, next slide here. In the figure, P is the midpoint of NQ. Now, as soon as I see that word right there, I immediately should be thinking, all right, it's in the middle, therefore my 2 segments are congruent. I'm going to take my stylus here, and I'm going to put tick marks on those. That means they're congruent. Okay, so number 11 says PQ is congruent to what? Well, I just marked up my figure. PQ is congruent to NP. So what is the value of x? Well, what does congruent mean? Congruent means equals. So if PQ is congruent to NP, that means PQ equals NP. And PQ is 2x plus 4, and NP is 3x. Subtract 2x from both sides, I get x equals 4. To find all three segments, simply take that 4 and plug that back in. So for NP, 3 times 4 is 12. Therefore, I immediately know that PQ is also 12 because they must be congruent. And NQ is simply 12 plus 12, which is 24, just like we did in the last couple problems. Number 14, D is the midpoint of EF. Again, I'm going to stop right there. I'm not even going to look at the rest of the problem. I'm going to draw that picture. So I'm going to draw EF. Now it says D is a midpoint, so do your best to put D exactly in the middle. Even if it's not in the middle, it's fine, because what you're going to do is you're going to take your finger or stylus and you're going to go ahead and put tick marks there. That means they're equal. I know ED is 4x plus 6. I know DF is 7x minus 9. Now notice they didn't give us anything for EF here, but we don't need it because they're a midpoint. So that means that ED and DF must be equal. I know that ED and DF must be equal because of the word midpoint. So then 4x plus 6 must equal 7x minus 9. Subtract 4x from both sides. Add 9 to both sides. And divide by 3. Now the question says, find all these measures. No problem. Take our 5 and plug it back into either of these. 4 times 5 plus 6, ED is 26, which means DF is also 26. And then EF is 26 plus 26, or 52. All right, 15. Again, there's those words. B is the midpoint of AC, so I'm going to stop right there and I'm going to draw that picture out. Again, put B exactly in the middle as much as you can, but go ahead and put tick marks on there so you know that they're equal. I'm using 2 tick marks this time. This time we are told AB is 3x plus 6 and BC is 2x plus 14. Again, because it's a midpoint, we know those two little segments are congruent, so AB must equal BC. So 3x plus 6 must equal 2x plus 14. Subtract 2x from both sides. Subtract 6 from both sides. And now it does say to find x and AC. All right, so we don't know what AC is, but that's okay. We know what these two segments are. So if we put 8 into here, we get 3 times 8 plus 6, which is 30, which means this is also 30. So an AC must be 30 plus 30, or 60. Last one. If EF is bisecting AD, so the key here is what segment is doing the bisecting and what segment is being bisected. EF is doing the bisecting. So EF is the bisector. AD is the one that's being bisected. So this segment right here is the one that's being cut in half. Okay, what that tells me is that this segment AC and this segment CD must be equal. Okay? So the picture here, they don't tell us a whole lot of information here, but they do tell us that AD is 6x minus 4 and that AC is 4x minus 3. So just look at the picture. Are those two segments equal? I hope you're not saying yes. But what is equal to the red segment? What is equal to AC? Well, that would be this segment over here, CD. So if that's 4x minus 3, I could put another 4x minus 3 right here. And now what we can do is we can do what we did all the way back in these problems. Number 10. I can say little segment AC plus little segment CD equals big segment AD. So 4x minus 3 plus 4x minus 3 equals 6x minus 4. Combine like terms. Subtract 6x. Add 6. And divide by 2. And then it does say to find the measure of CD. CD is 4 times 1 minus 3, which is 1. And that's it for 1.2. Again, I would advise you at this point to stop and do the 1.2 homework and check back here for section 1.3.